All right, so for this review here, I do notice that this is an exponential function, right, with an exponential decay because this number is less than 1, so we got a decay. That the 1/2 is done. That's all that tells me. The 3 has been a stretch, like a vertical stretch, also called a vertical dilation. The -2 right here is moving you to the right 2, and then this is moving you down 5. Okay, so the asymptote, exponential functions have horizontal asymptotes. So it was at y equals 0, now it's down 5, so y equals -5. So I can go ahead and draw that on there. All right, now that we know how to solve log and exponential equations, you need to be able to find the x and y intercepts by yourself without using the calculator for calculations, but like by plugging in 0 for x or y. So if you want the x-intercept, I'm plugging in 0 for y. So I got 0 equals 3, 1/2, x minus 2, and then minus 5. So I got to clean this up. I got to add 5 and divide by 3. So that would be add 5 is 5, divide by 3 there. So I'm left with 1/2 to the x minus 2. All right, so this is an exponent problem that I don't know how to solve. I can't change this into a power of 1/2, so I'm going to write it as a log. So log, my base is 1/2, so I'm going to use 0.5. My answer goes here, 5/3 equals x minus 2. So this is something I would put in my calculator. All right, so I put this in my calculator. 0.5 to the x minus 2 equals 5/3. That's what we're saying. So press math, go to log base, put in 0.5 and 5/3. All right, there we go. And then I'm going to go ahead and add 2. So my x-intercept is 1.263, or how about 1.3? So 1.3 and 0. My y-intercept is much easier. I get that by plugging in 0 for x right here. So I'm going to have f of x equals, or y equals 3, 1/2, and that's going to turn into a -2 because 0 minus 2, and then minus 5. Well, I could put that in my calculator, but also, it just flips the fraction, right? So this just becomes 2 squared. So 2 squared, and so that's 4 times 3, that's 12 minus 5 is 7. So 0, 7. So I can mark these on here. So x is 1.2, 0 is 7. Okay, and it's a decay problem. So it takes a while to come down to here, I guess, but basically I know now that my graph goes like this, and it's gonna eventually come down towards my asymptote. All right, I guess the only thing not on here is talking about my end behavior. As I go to the right, the graph comes to -5. As I go to the left, the graph goes up to infinity. So in case you have a question on that. My domain, this graph goes everywhere left and right. The range, it does not go past -5, so -5 to infinity, not including -5. All right, and then graph this on your calculator to confirm, but that's what it looks like. All right, over here, list of transformations. So I have a log. The base doesn't matter, whatever the base is, the base is. So it's moving to the left 3 and down 1. All right, the asymptote. Logs have vertical asymptotes because they are the inverse of an exponential. All right, so this left 3, my asymptote was at 0, so it's moving to the left 3. So x equals -3. All right, x and y intercepts. So I put in a 0 for y. So 0 equals log base 2 of x plus 3 minus 1. We'll move the 1 over. All right, now 2 to the 1. Well, 2 to the 1 equals 2, has to equal x plus 3. And so x equals -1. So -1, 0, my asymptote, x equals -3. All right. So now my y-intercepts, I'm plugging in 0 for x. So I got f of x equals log base 2 of 3 minus 1. So right here, I'm pretty much stuck using my calculator because I don't know a power of 2 that makes 3. So I'm just but I just want you to be able to think about this in general. All right, so math log base 2 of 3. All right, and then take away 1. So 0.584. 585. So 0 and I'll just say 0.6, I guess. Okay. All right, just for rounding purposes. So 0 and 0.6, so right about there. So there's my log function coming up here and going towards my asymptote. So my end behavior, as I approach -3, the graph goes to -infinity. As I go to the right, it keeps rising up to infinity. My domain, I can't go past -3, so -3 to infinity. My range is everywhere. It goes up and down forever. So -infinity to infinity. So notice the opposite behavior, right? The inverse behavior. Okay, so let's see. All right, so over here, let's see. So equations of asymptotes. So when I have an exponential function, here's exponential, exponential. Exponential functions have horizontal asymptotes, and they are controlled by this number right here. So that would be y equals -14. They do not have, what's it called? Horizontal, vertical asymptotes. So I'll put NA. All right, and so this one will be y equals -45. All right, it does not have that. All right, left 20, down 3. So a log function has a vertical asymptote. When you move it left, that's what affects it. So this guy right here, so x equals -20. So graphing these and trying to find the asymptotes in the calculator are going to be hard because these numbers are so large. All right, so oops, that goes here. All right, so let's check them out. So the zeros, let's practice those, finding those on the calculator. So let's see. I got all this other junk in here. So we have e to the x plus 7. So let's move to the left 7. It's a growth problem. Minus 14. Oops, hang on. Zoom 6. All right, so I see my 0 right there. 1, 2, 3, 4. It looks like it's between like -5 and I'll say -3. So I press second trace, number 2, and let's do -5 for the left and -3 for the right. So it gives me that little area to look in right there. All right, so -4.36. And I'll go ahead and just make it a coordinate, okay? So next one, a log function, so ln x plus 20, and then -3. All right, so right in there. So I'm going to say, I'm just going to look from like -5 to 5. Oops, what did I do? Oh, not number 5, sorry, number 2. -5 to 5. All right, so 0.09. All right, and the last one. So I got 5 to the x minus 45. All right, so right between 2 and 3. 2.37. And I suppose you could have also put like x equals for those answers too. All right, here we're going to expand and simplify if we can. So first of all, division turns into subtraction. So I have ln of e to the third minus ln of this guy, so 5x minus 2. And remember, fourth root is a 1/4 power. So I'm going to bring this 3 out, 3 ln e, and 1/4 ln of 5x minus 2. So that one's done, but this guy, ln e, remember, ln is log base e, so e to the first is e again, so this is just a 1. So I have 3 minus 1/4 ln of 5x minus 2. All right, that's my final answer. Over here, I got 1, 2, 3 parts, so I have log base 5 of x plus 4. It would be squared, but I'll put that 2 out front, minus both of these, so minus log base 5 of 5, and this is on the bottom as well, it's divided, so minus log base 5 of x squared, but that's a 2, right? So only correction, or only next thing I would do is this guy right here. 5 to the first power is 5 again, so that's going to be a 1. So I'd replace that with a 1, basically. All right, condense. So 12 goes back, 5 goes back, and oh, actually, before I do that, Look, I got 12 log of x minus 5 log of x, so that's 7 log base 5 of x. That'll save me some trouble later, plus log base 5 of 3. So this is x to the 7th times 3. So log base 5 of 3x to the 7th. And you could have done that later, like you would have gotten x to the 12th over x to the 5th, and x12 over x5 reduces to x7. So it's just easier to do it here. All right, over here, we got this 4 coming up, we got this 2 coming up, and this 1/3 coming up. All right, so it's all multiplied, so ln, I get x to the 4th, this is a 16, so 16x to the 4th, and that's going to be a cube root of 5x plus 2. So you can write that as this to the 1/3, or you can put the cube root, up to you. Right, down here on number 8. So on number 8, you have pressed your, your stat button and get this data put in there. So I got 1, 2, 3, 4, 5, 6, 7. Alright, so your data's in when exponential regression. So that's stat calc and number 0. And you just have to store it in y1, so alpha trace. Alright, so there's my equation. So I got basically anything to name it. We'll just do y equals 598.601 and 1.188 we'll put to the x. Okay, and so asking what's happening at 12 days. So I just have to do alpha trace y1 of 12. Alright, so y1 of 12 is 4743.2. So we'll say 4,743 bacteria. Okay, to make sense of our word problem. Alright, our equations page. So this equation here, I noticed that I do know these are both powers of 5. So this is 5 squared, 3x plus 2 stays. This is 5 to the 3rd, and 4x stays. So I basically have 5 to the 6x plus 4 equals 5 to the 12x. So now I don't need the 5's anymore. Like, I basically know that 6x plus 4 has to equal 12x. Alright, so take away 6, so 4 equals 6x. So x is 4 over 6, which is 2/3. And I don't have to check exponentials, they can take anything. Alright, over here, take away 4, so I have log base 8 of 2x minus 1 equals 2. So when I have a log equal to a number, I write it as an exponent. So 8 squared equals 2x minus 1. Well, 8 squared is 64. So I add 1, so that's 65, and divide by 2. So 65 over 2 is my answer. If I put 65 over 2 back in here, it does not cause this to be 0 or negative, so I'm good. Alright, let's move this over. So 3 to the x plus 4 equals 12. I do not know a power of 3 that I can change 12 into, so it's not like this problem. So an exponent problem that I do not know that I can do this trick for, I have to write it as a log. So I write log base 3 of 12 equals x plus 4. So 3 to the x plus 4 equals 12. That's what that says. So log base 3 of 12 is something I find in my calculator, my log base. Alright, and then I'm going to have to subtract 4. So 1.7 nearest thousandth rounding, so that's 3 places. 738. So x equals negative 1.738. Okay, over here, I see a log rule. I could put these together. So I have ln. I have to multiply 2x times this, times 4 minus 16 over x equals ln of 3x minus 2. So I'm going to drop these logs because they're same on both sides, so I just know this has to equal that. So I can multiply this out. 2x times 4 is 8x. Hey, what you need?
Hi, do you think I could come into Soar to take the maths with me? Like the maths with me? Because I wasn't able to come yesterday because I had a doctor. Is that okay?
I don't,
Or can I ask Miss Reed?
you can ask Miss, I don't have the paper at all.
Does she have it?
Yeah, but I don't know. You can ask her, and then I'll get it from her. She says okay. All right. Okay. All All right, so 2x times x is 8x, and 2x times 16 over x. So if you multiply 2x times 16 over x, the x's cancel, and you get 32. A equals 3x minus 2. So not that bad at all. So I'm going to take away 3x, that's 5x. I'm going to add 32, so that's 30. So x equals 6. So let's check this out though. If I put a 6 in here, that'd be 18 minus 2, not 0 or negative, and that one's fine. 16 divided by 6 will be 2 point something, so 4 minus a 2 is not going to be negative or 0. All right, here I'm going to get this ln alone, so take away 8. So I have negative 2 ln x equals negative 12. Then I have ln x equals 6. All right, so this is a log equal to a number. It's basically just like this problem up here. So remember, ln is base e. So I will write e to the 6th equals x. And so there you go. X is e to the 6th. And you can go on your calculator and get a decimal for it, but just leave it like that. All right. I think I would like to put this on the other side so that I can have these logs to put together. So I have 2 equals, I got log base 6 of x minus 5 plus log base 6 of x. So now I notice that I have addition, so I can multiply. Do my condensing. So I have x times x minus 5. All right, so let's write it as an exponent. 6 to the 2, well that's 36, equals x times x minus 5. Well, x times x minus 5, that is x squared minus 5x, and that's 36. I'm going to move my 36 over. All right, so now I am set to factor. 9 and 4 does the trick here. Minus 9 plus 4. So my answers are 9 and negative 4, but negative 4 is no good for me, so I can't accept that. My only answer is 9. All right, over here, I have condensing I can do right here. So I have log base 10 of x squared minus 8 equals, this 2 is going to go up, so it's going to be log of x squared over 2. All right, so let's go ahead and drop these logs. Oh, that's fine. I don't care. I'm just finishing. Oh, is that girl? Bennett wants to. Okay.
I told her, like, I already gave out blank ones to people who wanted to, like, take it home and continue working on it because it was really hard.
Oh, really? Okay.
So,
all right.
I don't know
It's
how.
fine.
I was like, I'll just tell you that. I don't know how you feel about that, but
It's
anyway,
fine.
if she's just doing it for bonus and you want to
That's-
allow her to do it,
Okay.
there it is.
You'll have to give me the
Yeah,
answers then.
top score was 2.
Oh, God. That's so rude. Oh.
Really hard.
Oh. All right. Okay, so we got x squared minus 8 equals. Yeah, that's fine. All right, thanks. So I set these equal to each other. So I'm going to multiply this 2 over here. So I'm going to get 2x squared minus 16 equals x squared. And I'm left to solve this. So take away x squared, so I get x squared
I know
minus
what
16.
also to take away.
I'm making a video. Could you stop?
I'm so
Thanks.
sorry.
We got x squared equals 16. And so I take my square root. It's too much in the morning. All right, so I get x equals plus or minus 4. So be careful. The negative 4 is no good for you because negative 4 put in here makes a log of a negative, and you can't have that. So the only answer you keep is positive 4. So negative 4 would be an extraneous solution. All right, so we need to get this part alone. Take away 8. That makes negative 18. Divide by negative 6, so I have e to the 5x equals 3. So this is an exponent problem that I can't solve by doing a trick. So it's just like this one. I have to turn it into a log. So I'm going to write log base e. So e to the 5x equals 3. So this is just ln 3 equals 5x. So x is just whatever ln 3 is, all divided by 5. So if I get my calculator, and if nobody else interrupts me, and I want to divide this by 5. So 0.22, I guess I'll round that off. 0.22. Or just leave it like that. All right, here we go. Last page. So you have a laptop depreciating at 25% a year. So that means you're keeping 75% of the value. So when you're doing V of t, you're starting at 2,400, and 0.75 goes right here, because that's how much you're keeping of your value. All right, laptop in 3 years, all we gotta do basically is V of 3. So I would put in 2400, 0.75 to the third. All right, so it's money, so $1,012.50. That's a lot gone. All right, so it's asking you how many years does it take to get below 300? So I can just keep trying new numbers here. So I'll do 4 years. All right, let's skip ahead. Let's do 6 years. All right, I think I almost have it. 7 years. Uh-oh. All right, let's do, oopsie. 8 years. There we go. So it's going to take 8 years. Now, we got that by guessing and checking, but what can also be done is you can put basically the number that you want, 300, right over here, and we can solve the equation, all right? But we haven't done that in class yet. We're going to do it after the test, actually, so you can just do guess and check for now. All right, over here, same question, but we have a growth rate, right? So my population is going to be 420,000 to start. And I got a growth rate of 2.2. So remember, that's basically I'm getting 102.2% back every year, right? So move my decimal back, that's 1.022 to the T. Okay, so in 2024, so from 1990 to 2024, how many years to go by? So you have to say, let's see, 10 to get to 2000, and then 24 more, so that's 34 years I'm gonna wanna see. All right, so we need to plug 34 into this thing. So I want 420, 1.022, power 34. All right, oh goodness, 880,000. Comma, sorry, 190, I think I'll say just 196. This is the people, right? Okay, has to reach 1 million. So let's try a couple more years. Let's do 36. No, let's do 38. Okay, how about 39? Oh my goodness. Let's do 40. All right, there we go. There's 1 million. So it's going to take 40 years. So 40 years, that will be 2030. All right, these little facts down here. So we're just going to do these real quick. I got 7 to what power makes 7? Well, 7 to the 1. E to what power makes E again? 1. When these things match, your answer is always 1. 3 to what power is 81? 4. 5 to what power is 1? 5 to the 0 is 1. 25 to what power is 5 again? So basically the square root of 25 is 5, right? So that has a 1/2 power. ln 0. Can't be done. Can't do the log of 0. Also, can't do logs of negatives. Can't be done. All right, remember this is a 10 here. 10 to what power makes 100? Well, 10 to the 2 makes 100. All right, here, 7 can come out there, so 21 ln e. And look back here, ln e is 1. So I'm just going to say this is 21 times 1. Right here, 4 to what power makes 1 over 64? Well, I know that 4 to the third is 64, so to get it to go to the bottom, it'd have to be a -3. All right, this one, I'm just going to flip this over to 6 over 1 and make it a +2, so that's basically 36. Here, 3 to what power makes square root of 3? Well, that would have to be a 1/2, because a 1/2 power, a square root, is going on the 3. All right, don't forget to look over these things here, because 2 of them are going to be a question on the test, so go back and study from there. All right, I'll see you later. Bye-bye.